Okay, and welcome to our physics class. We'll be talking about electric charges, but this is under electricity. So, what is electricity? Um, Electricity, when you look at the word electricity, we are talking about something that has to do with the flow of electrons. Okay, and when we talk about this electricity, we can actually split electricity into two. We have static electricity and we have current electricity. For now, we'll focus on static electricity. Talking about static electricity, this is the kind of electricity where current flows from one point A to another point B without the actual movement of the particles in that substance. Okay, so we are not actually allowing, for instance, if we have a copper wire and we allow current to flow from one end to the other, okay, without actual movement of particles that make up the copper. So we can say that that's a form of what? Static electricity. Okay? Then in electrolysis, we actually discovered that electricity is transferred from one point to another by the actual movement of the particles of the electrolyte. But don't worry, we'll get back to that when we're talking about what? Current electricity. Good. Now, talking about static electricity. Well, static electricity, we are actually talking about electricity that has to do with electrons. And what exactly are electrons? If you remember, all substances of matter are made up of atoms. And these atoms have a nucleus at the center. Nucleus. And inside this nucleus, we even have smaller particles. Some of these smaller particles are charged. Some of them are neutral. The positively charged ones we refer to as protons. And those ones which are neutral, we refer to them as neutrons. But we know that atoms are neutral generally, okay? When it comes to charges, they're electrically neutral. Now, if they're electrically neutral, definitely they would have what? Negative charges to balance these positively charged protons. And those negative charged particles are referred to as what? Electrons. Okay, now one interesting thing about atoms, for them to be electrically neutral, if there are three protons, then definitely there will also be three electrons to make sure that everything is balanced. Okay, so every atom is electrically neutral, which means the number of protons and number of electrons are the same. Okay, so looking at this, we can refer to electrons as negative charges. Negative charges. And we can refer to protons as positive charges. Now, when it comes to transfer of charges or charging of particles, we mainly focus on the electrons. Why? The electrons are light and easy to be transferred from one atom to the other. Protons are heavy and also found in the nucleus of the atom. So it's not very easy to transfer the proton of one atom to the other. So in such cases, charging of particles has to do mainly with the transfer of what? Electrons. Now, let's look at this atom. Let's look at this substance. This substance is made up of millions, if not billion, I don't say million, like let's say numerous atoms. Okay, because um, atoms are very very small. That thousands and millions are kind of tiny quantities for them. Okay, so now this substance or this metallic bar, for instance, is made up of atoms. Now, these atoms, don't forget, they have nucleus and they have electrons around them. Now, these electrons move around in shells, not exactly like this, but for this illustration we'll be using this diagram. Now, if this is atom A, and this is also atom B, now atom B has its own electrons moving around it also in shells. Now, the more energy these particles have, the further these electrons can actually move because they acquire more kinetic energy to move about. Okay? Now, sometimes we can decide the atoms of different particles can come too close to each other, which now affects a transfer of electron. For instance, if electrons acquire enough energy to move about in this point, you realize something. These electrons, which are attracted to the protons in this neutron, are now much closer to this. Hence, they can fall within the nuclear force of this other atom. Hence, these electrons can be transferred. Now, instead of moving around this, they can be transferred to this other part. Now, this transfer of electron, we can say that A has actually charged B. Okay, so A becomes, when A loses electrons, A now becomes what? Because it has lost, when the electrons are 3, the protons is also 3. If electrons are lost, that means this atom will have more protons than electrons. A becomes positively charged. Now, if B gains electrons, let me say B has 3 electrons and 3 protons. If it gains one more electron, we can actually say that B becomes negatively charged because it is now more it has more negative charges than positive charge. So B becomes what? Negatively charged. And one interesting thing about charged particles is that light charges repel. Light charges repel, but unlike charges attract. So when we talk about like charges and unlike charges, if A meets another positive charge, they will repel each other. If B meets another negative charge, they will repel each other. But if a positive charge meets a negative charge, they will attract each other. Okay? So these are the things we need to understand about what? Electric charges. But if this atom can transfer charges to this and this can transfer to this, at the end of the day, we realize that charges can be transferred until charges get to the electrons move to this other end. Okay? Now, this flow of charges leads to what we call flow of currents. Okay, but we get to that. So, substances that allow charges to flow through them, okay, substances that allow electrons to easily pass through them, we refer to them as conductors. So when we're talking about conductors, they allow electrons to easily pass through them. And what are conductors? All metals are conductors. Not only metals, we also have graphite, which is not a metal, but it's also a conductor of electricity. Okay, then we can have things like a damp air salt solution. They are also what? Conductors of electricity. Then those ones that don't allow electrons to flow through them, we refer to them as insulators. Generally, non-metals are insulators. Non-metals, we have things like a dry wood. They are what? Insulators. Plastics, they are insulators. Polythenes, okay, polythene bags, they are what? Insulators. Why? Even a ebonite rod, glass, these are insulators because they don't really allow electrons to easily flow through them. So these kind of substances that allow electrons to easily flow through them are conductors. The ones that don't allow electrons to flow through them are what? Insulators. Now, flow of electrons doesn't imply the directional flow of current. We'll get to these currents in time. So, in conclusion, we should remember atoms contain what? Nucleus, which has a positive protons and it has negative electrons moving around them. But these electrons can be shared as atoms move over each other. Okay? Now, this share of electrons leads atoms to become what? Charged. Okay? So some become what? Positively charged when they have more protons, or they become negatively charged when they have more electrons. But one thing to guide them is like charges repel and unlike charges attract. Substances that allow this flow of electrons are referred to as conductors, and substances that don't allow this flow of electrons are referred to as insulators.